And we're rolling. Welcome back to Roycewood Automotive. We just want to do a short little video here of the test of the Zilla and the hairball, which we have in. We've wired the HEPA pedal, and that's all connected. Obviously, a lot of wiring still to go. I have to hook up my RPM activated switch yet. I have to hook up the voltage meter for out here under the hood, but we just wanted to do a really quick video of the car running under Zilla power at this point. I do have a small power supply providing power. It's not hooked up to batteries right now, so it's very possible that will kick off during the test, but we just wanted to give an overview of that. One little problem, I'm not picking up my speed sensor, so I'll have to look into that, see why that's not working, but that could be a whole number of things, wiring or something like that, but I'll get that figured out. But we wanted to do a quick test, so here we go. We have power up, key start. Zilla's pre-charged and ready. The red light's out. You want to show them the motor? Or? Yeah.
Here we go around.
Show the motor. Yeah. Still have to mount the accelerator pedal in the car, but you can see it's very responsive. And we kick the brake. Zilla recognized the power had dropped out and disengaged the main contactor and has turned our check engine light back on. So there you go. That's a wrap for this segment. Right button. Okay, we're back here at Roycewood Automotive. One of the things I want to do with my setup for the heater, everybody's using the ceramic PTC heaters. Guys, those are available. You can go to Home Depot and buy the little $24 ceramic heaters, and I think I bought this one brand new for maybe $21. It was on sale. This is the same ceramic heater that is available at other places. But you can take those little heaters apart, and there's your ceramic heater core. I kind of scavenged the fan out of the one that I had as well, because I wanted to run some tests on it. And some of those tests were a matter of control. A lot of people just turn these on full blast, and they have on or off. These heaters get quite warm, which is a good thing. Again, it is a positive thermal coefficient, so it's not going to overheat. But I wanted a little bit more control out of my air temperature for my vents in my car. And so one of the things that I've done here is I've set up a little experiment, and I'm using the TO220 MOSFETs. These are like 200 volt, 200 amp MOSFETs, and these are available online if anybody's interested. I've actually got quite a few of these. If anybody wants some, you can contact me through the I don't know, I'm kind of everywhere. I guess people know who I am, but anyways, and we've set it up with a three-way switch, and this little switch is actually harvested from the heater itself that we bought at Home Depot. And what we're going to do here is basically turn on these sections one at a time. and that way we can control the amount, not only our amperage draw, but the amount of heat that this little heater puts out. And it's very evident when we do that, when the power is applied. And I don't know if you can see it or not. This is my power supply here, and that is our amperage needle right there. And what we're going to do, we're going to go to our first setting, and we've come up. It'll peak at about 5 amps and then pull back to about 2.5 amps. And what that does is turns on this upper section right here, which is already quite hot. I mean, I really can't even touch it. But you know, by the time you get your air through your heater out here, it's fairly warm. It's not hot or anything like that, and we've got some pretty decent heat, you know, for what we want to do. We go to our next setting on our 3-way switch, and we come back down and we can see our amperage. It spiked to about 7 amps and then pulled back to about 5, which is what we would expect in this situation. And the interesting thing that I've noticed, and of course we've got, you know, quite a bit more heat. I've now got this element on down here and this element on here. The center is not on. We go to wide open and we start pulling. Oddly enough, it almost doubles in its amperage draw. We've went to about 10 amps, almost 11, and now we've started to pull back as the center element starts to heat, and it pulls back to about 8 or 9 amps, up from the 5 amps earlier. And it will stay about right there. It doesn't move. And at this point now we've got a tremendous amount of heat coming out of the PTC heater. At this point it's very warm and you know, putting out quite a bit of heat, so we would consider that our wide open setting on the PTC heater for the electric car. And I just thought that would be an interesting way to control the heater, so it's not full on or full off like a lot of folks are doing. And again, these MOSFETs can handle 200 volts and 200 amps. That's their peak. Obviously, I'm not running them there. My car's only running at 180 volts. But you know, clearly we're not approaching their amperage draw rating, which, like I say, is 200. And obviously, you derate those a little bit. Of course, to turn it down quickly, we have our little 22K ohm resistors from gate to source, and that flattens the capacitive effect on the MOSFET there, and it'll start turning. And we've already, you know, started to cool off. We go to the next setting. Of course, that drops us down, and it immediately, you know, you feel the effect of the air temperature coming from the heater core. And our amperage draw now is back down to the 2.5, where we started with just one section of the PTC heater right there. And of course, if we go all the way off, we've dropped to 0 on the amperage draw, and we're now very cool air coming through. No heat being generated at all. So I just wanted to share that with everybody. This heat, you could use any heat sink. I had this heat sink lying around that's from another setup that we had here, something else we were doing. But anyways, again, just wanted to let everybody see what we were doing there as far as controlling the temperature of the PTC heater in your electric car. That way you don't have to have it full on or full off. Which again, you know, the amperage draw is quite substantial. I mean, if you don't have to consume amps, why would you? So, like I say, these MOSFETs can be found at DigiKey or anywhere like that. I believe that's where I found these. You don't have to use this style of MOSFET. I just happen to have these lying around. Again, I bought the PTC heater at Home Depot. It's a 1500 watt ceramic heater. You can buy those at Home Depot, and you can just take them apart. You've already got your control switch, and you're all set. One of the things that I want to stress here is that if you do a little bit of research, you can find these components pretty readily available for not a lot of money. I mean, this, of course, my project is EV on a shoestring, and that's, it's not EV on $1 million budget or anything like that. Most folks don't have a lot of resources to put these things together, and I just want to try to show a way of doing that without spending an enormous amount of money. I mean, you're obviously going to spend some money, but it doesn't have to be upwards of $60,000, $70,000 to have the electric vehicle that you want. And again, this is just one way to do the control of the temperature of the PTC heating element. And again, available at Home Depot for about 20 bucks. And you've got you get your switch, and you get your PTC heating element. That's an AC fan. I don't know if many people who are going to run it on AC in the car, but again, I'm using an inline blower very similar to what I used for the blower on the motor. And there you go. We'll stay in touch.